Okay, let us look at the questions for Coulomb's law. The figure below shows 3-point charges are placed in the shape of triangular. Okay, you have 3 point charges here, Q1, Q2, and Q3. Determine the magnitude and direction of the resultant electric force exerted on Q1. So the things he asks you is you want to find the magnitude and direction, okay, of the force, okay, on Q1. On Q1 only, okay. Don't draw the force on other charge, only draw the force on Q1 only, okay. And he want the force, okay, not field strength, not other thing, yeah. It's the force, electric force. So for force is a vector, is a vector, so it has both magnitude and direction. Even if the question just simply asks determine the resultant electric force exerted on Q1 without the word magnitude and direction, you still have to find these two, magnitude and direction both, because force is a is what? Force is a vector. If questions about vector, automatically you need to find both magnitude and direction. You must give direction also. If you don't give direction, you will lose marks. Okay? If the question simply just asks determine the force exerted on Q1, you need to give direction also. Even the question didn't ask you explicitly. Okay? So now, only the force on Q1. We begin by drawing the vector diagram. So first of all, we look at the equations for electric force. Electric force equation is KQQ over R squared. So for force, it consider both charge. It consider both point charge and test charge. Q1 and Q2 R squared. So draw the force on Q1. Okay, let us draw the force on Q1. So you have how many force? Q1 and Q2, they both experience a certain force. Q1 and Q3 also experience a certain force. And this is the way to calculate it. Yeah, this is the formula to calculate it. First of all, we draw the vector diagram on Q1 only. Yeah, don't draw the force on Q2 or Q3. Only because the question asks only on Q1. Okay, so between 1 and 2, yeah, because force it need to consider both charge, yeah, the point charge and test charge. So you need to consider both charge. All right, consider both charge. So if both has a same charge, positive, then they will repel. Okay, repel each other. But if both have opposite charge, positive and negative, then they will attract each other. Okay, that's the way you find the direction. So between 1 and 2, they are opposite charge. Opposite charge, they will attract. So I draw the force there. Okay, attract. This is, what is this? This is F12. No. The force on 1, isn't it? The force on Q1. So Q1 is we can say Q1 is the test charge. Okay, Q1 is a test charge and Q2 is a point charge. All right. So the Q1 experience the force, isn't it? Q1 experience the force. So the force should write as F21. 21. The number behind is the one who experienced the force. Okay, Q1 experienced this force, so we write as F21. The one, yeah, the number behind is the one that experienced the force. It's the charge that experienced the force. So write as F21. Don't write as F12. Okay, F21 means F2 on 1. Okay, so Q1 is attracted to Q2, okay, because they have opposite charge. How about 1 and 3? 1 and 3, they have the same charge. Negative and negative, same charge. So they repel each other. They repel each other. So we can say Q1 is being repelled by Q3. Yeah, they have same charge. Repel. This is, what is this? This is F31. Yeah, the number behind shows the one who experienced the force. Okay, Q1, yeah, because the question asks for force on Q1. Q1 experienced all this force. Okay, he experienced F21 and F31. Okay, yeah, these are the two forces. So that experienced by Q1. So first of all, you need to find out how much is F21 and F31 using the formula K cube Q over R squared. Okay, let us begin. So let us F21 between 1 and 2. So K is 9 exponent 9. Very easy to remember. In fact, you can find 9 exponent 9, the Coulomb's constant, in the list of constant that will be provided in your exam. Yeah, list of constant. So, but it's a very easy value to remember. 9 exponent 9. Okay, K is 9 exponent 9. Okay, and then how about the Q1? Q1 is in micro Coulomb. Micro Coulomb, you change to SI unit. Micro is a -6. So it's a 1.2 exponent -6. Change to SI unit. Micro is -6. How about Q2? Do you see that? For force is a vector. Okay, vector, the charge, you ignore the negative sign. Because for vector, when you find the value, the magnitude of force, you can just ignore the negative sign. Okay, you can just ignore the negative sign. So you see, actually Q1 is a -1.2, -1.2, but the negative I don't put into the equations. You no need to put in the negative sign here. Okay, you can just ignore, because what I concern is only to find the magnitude. Okay, I don't put the negative sign here. Okay, if you put the negative sign, it will mess up the calculation. Yeah, so you can just ignore the negative sign here. Just the magnitude. Okay, the negative, positive and negative sign, later on you will have to put in this part. Yeah, the directions, which I will explain later on. Okay, so let us so Q1 initially is actually actually Q1 is actually -1.2 microcoulomb, but I purposely don't put the negative sign here. Yeah, I just ignore the negative sign. Okay, because force is a vector, when you calculate the force, the charge, you can, if it is a negative charge, you can just ignore the negative sign. No need to substitute the negative sign. Okay. All right, let us continue. And Q2 is a positive charge. Okay, it's a 3.7 microcoulomb. So I change to SI unit, 3.7 microcoulomb, which is -6. Okay, -6. All right. So divided by the distance between the two charge. Distance between Q1 and Q2 is 15 cm. Centi. So change to SI unit. Divide by 100. So you will get 0.15 meter. 0.15 meter. Don't forget, you have square. Many students forget about this square. They just substitute the distance, and then they forget about the square. Then you lose mark, which is so so careless. So the square, make sure you square the distance. Many students forget about the square of distance. So in the end, what is the force? What is the force? It is I get 1.776 Newton. The unit for force is Newton. All right, that's the force. Now let us move on to F31. F31. Okay, again, Q3 is also a negative charge. Okay, Q1 is negative charge. Q3 also negative charge, isn't it? Q3 in fact is a negative 2.3 microcoulomb. Both, you know, Q1 sorry, yeah, actually both Q1 and Q3 both are negative charge. Q1 and Q3 both are negative charge. But when calculation, you can ignore the negative sign on the charge. I just want to concern about the magnitude. As long as you want to find a vector, the charge you ignore the negative sign. Okay. Later on, the electric field strength also is a vector. When doing vector, the charge you just ignore the negative sign when finding the magnitude. Okay, K again is 9 exponent 9. 9 exponent 9. Okay, Q1 is negative 1.2. Okay, negative 1.2. But I just ignore the negative sign. No need to substitute the negative sign. So it's only 1.2 microcoulomb. So it's negative 6. And then Q3 is a negative 2.3. Okay, Q3 is a negative 2.3. But you know, 2.3. Yeah. So I ignore the negative sign. So I just put 2.3 microcoulomb, right? And then divided by the distance between these two. Distance between Q1 and Q3, which is 10 cm, right? 10 cm. So it is 10 cm, centi. So divide by 100. So you get 0.1. So it's 0.1 meter. Okay, is that correct? What is missing? What is missing? Again, you are careless. You are careless because you forget about the square. Square the distance. So don't forget, yeah? Don't forget the square of distance. So after I calculate, the answer is 2.484 Newton. That is the force for F31. Okay? So now I got the each forces, F21 and F31. Okay, F21 and F31. So what do I do? So I resolve, you know, F21, F31, they have directions. So especially F21 only has X component, but F31, it has both X component and Y component. So you have this because this is a vector, they have directions. So they have X and Y component. So you need to do a table. Table where you resolve the force into X and Y component. Before, you must resolve in the X and Y component before you can do any addition or subtraction of vector. Okay? Make sure you still remember what you learned in semester 1 when you're dealing with vectors. Okay, so F21 is 1.776 Newton, which is direction to the right. Okay, direction to the right. Remember, directions, you have positive and negative sign. Okay, just now the charge, you ignore the negative sign. Okay, you ignore the negative sign. Actually, the sign positive and negative is just to show direction. Okay, it's just to show direction. For calculation of magnitude, you ignore any negative sign. The charge, you ignore the negative sign. So all the force value, you get positive value. Make sure for the force value, all you get positive value. You only have positive or negative sign when you find the XY component. When you want to add in the directions, you put in the positive or negative sign as their directions. Okay, as you remember before, what you have learned before. This one, the directions. I think in the notes I already show you. Going up is positive, going down is negative, going to the right is positive, going left is negative. So for any x component to the right is positive, x component to the left is negative, y component going upward is positive, y component going downward is negative. Okay, so you only put the negative signs for direction to the left and direction downward. Okay, so now so let's do F21. F21 is to the right. To the right is positive. Okay, direction positive. So direction is positive. I actually don't have to put in the positive sign, but I just want to show the direction here, so I put in the positive sign. Okay, so okay, so so the answer sorry. So this one is only the x component, so that means only has x component, and it is to the right is positive, positive 1.776. Okay, that's it. Newton. All right, Newton. So y component is 0. Yeah, just put a 0 there. Okay, 0 because it only has x component. All right, and then how about the F31? F31, it has both x and y component. For x component is positive, y component is downward, is negative. Okay, so for F31, x component is to the right, So the direction is, what is it? What's the direction? Direction is positive because to the right. Okay, so F31 is 2.484. So 2.484. Okay, 2.484. But okay, you need angles. Okay, because now you need to resolve F31 into x and y component. So you need angles. Okay, so you need angles. So you have 32 degree here. So how does it look like? F31 32 degree there. So yeah. So here is the axis. Okay, axis. So if here is 32 degree, that means below here, which is opposite angle, it is also 32 degree, isn't it? Yeah, the angle here is 32 degree, which is opposite to here, 32. So so this is the y-axis, and this part is the x-axis. Okay, the x-axis and y-axis. So here is 32 degree. So the 32 degree is with the y-axis. So for y component, you use cos 32. You have angle, use cos. No angle, use sine. Okay. So for this one, the x component, you have no angle. So you use the 32 degree. The degree that you must use sine 32. You must use what? You must use sine 32. Not cos 32. Yeah. Because the 32 degree is with y-axis. The y component should use the cos 32. Okay. Now, so it is sine 32. So what's the value after you sine 32? The value is 1.316 Newton. 1.316 Newton. Okay, so how about the y component? Y component is cos 32. F31 cos 32. But it is direction downward. So downward, you need to put in the negative sign to show direction downward. Negative sign means downward. Just now x component is to the right. X component is to the right, so it's positive. but y component is direction downward. Downward is negative. Okay, downward is negative. Now 2.484. Okay, 2.484 again, 2.484. But you have angle 32 degree with the y-axis, so you use cos 32. Okay, cos 32. Okay, cos 32. Sorry, cos 32 degree. So in the end, so after you cos, the answer is a negative 2.107 Newton. That's the y component. So now, what I do is, now after I resolve into x and y component, I can total up the x and total up the y. Total up the force on F, total up the force on X, total up the force on Y. Okay, let's total up. After I total up, I got total Fx, as 3 total Fx is equal to 3.0092 Newton. Total Fy is negative 2.107 Newton. Okay, yeah, negative 2.107 Newton. Okay, so now I got that. Okay, so you can see clearly the resultant Fx is positive. Resultant Fx is positive. The resultant Fy is negative, negative. So that means the total Fx is to the right because it is positive. Total Fy is negative means it's downward, direction downward. This is a total Fx, and this is a total Fy. So that means the resultant actually is maybe I can draw that. Over here, right? So total Fx, total Fx. This is positive 3.092 and negative 2.107. And then the resultant is this one. This one. So this is the total force that you need to find. Total force, and this is the angle theta that you need to find also as direction is below the positive x direction. Okay, so let's find out this total force using the Pythagoras theorem. Okay, Pythagoras theorem, which is a square root. Okay, let's find out. Okay, so let's find out. Yeah, so you have 3.092 square root plus the negative 2.107 square again, and then you square root the whole thing. Pythagoras theorem. So what do you get? So you get the resultant as 3.74 Newton. That's the resultant force. Okay, I got the magnitude of the resultant force. Now how about direction? Direction use tangent theta. So make sure you modulus it. Yeah, modulus it because I want to end up with a small angle. I want to modulus it. I want to make the value positive. So I will get a small angle less than 90 degree. I don't want to get a big angle. Okay, that's why I put the modulus sign. Put the modulus sign. So total Fy, initially it has a negative sign, isn't it? A negative sign, negative 2.107. But after I modulus it, it becomes positive. Okay, modulus it to make it positive. So divide by 3.092 Newton. Okay, so I modulus it. So in the end, I get theta, a small angle less than 90 degree. Okay, I don't want to get big angle. Okay, so I modulus it, make it positive. So I get the angle. After I anti-tangent, I get 34.27, 34.27, sorry, 34.27 degree below, sorry, yeah, it's below the positive x-axis, below positive x-axis. Make sure you must write which quadrant. Don't just write the angle 34.27 degree. It's not complete. You must also mention that it is below positive x-axis. Below the positive x-axis. Because you must draw the diagram first. You must draw this diagram. Then you can clearly see that the resultant force is actually theta degree below positive x-axis. That's the answer, the direction for resultant force. Okay, so you got the magnitude and directions for the resultant electric force exerted on Q1. That's the answer, magnitude and direction. Okay, so thank you for question 1. Okay, now move on to the next question. Thank you.